Myself, M. Karthik Kumar Reddy, working as an assistant professor in Nalla Narasimha Reddy Education Society's group of institutions in the Department of Civil Engineering in Foundation Engineering subject in Unit 4, that is Shallow Foundations. Till now we have discussed about the theory part in shallow foundations, and now I will explain more conversant with the use of Terzaghi's bearing capacity equation and by solving few more examples. Let us say here we are going to discuss about Terzaghi's bearing capacity equation problems. Let us say the first example is a strip footing of width 3 meters is founded at a depth of 2 meter below ground surface in soil strata, having soil properties as cohesion C is equal to 30 kilonewton per meter square and angle of shearing resistance phi value as 35 degrees. The water table is located at a depth of 5 meters below ground level. The moist weight of soil above water table is 17.25 kilonewton per meter square, kilonewton per meter cube. Now we will be using Terzaghi's bearing capacity equation to determine the ultimate bearing capacity of soil, the net ultimate bearing capacity of soil and the safe bearing capacity of soil for a factor of safety equal to 3. Now in this case, general shear failure criterion of Terzaghi has been considered. Now depending upon the description, this is the sketch which shows the depth of the foundation as 2 meter, width of the foundation, and we can see water table is present at 5 meters below the ground surface. Here phi is equal to 35 degrees, which is given in the question, and gamma, that is unit weight of soil, will be equal to 170.25 kilonewton per meter cube, and cohesion C will be equal to 30 kilonewton per meter square. Now for phi is equal to 35 degrees, the bearing capacity factors can be obtained by the plots available from the tables. Now if you use tables, then you can find that phi value is equal to 35 degrees, NC is equal to 57.8 and NQ is equal to 41.4 and N gamma will be equal to 42.4. Now from Terzaghi's equation, if you substitute this in the equation, Q ultimate will be equal to CNC plus gamma df NQ plus 0.5 gamma B N gamma. If you substitute respective values in the particular equation and solve it, you will get ultimate bearing capacity as 4259 kilonewton per meter square. We know that net ultimate bearing capacity is equal to ultimate bearing capacity minus gamma df, that is Q net will be equal to Q ultimate minus gamma df. So this will become equal to 4225 kilonewton per meter square. Now we can find out net safe bearing capacity. If we know net ultimate bearing capacity by dividing it by a factor of safety, now here this factor of safety will be equal to 3. So 4225 divided by 3, that will become equal to 1408 kilonewton per meter square. Now in order to determine the safe bearing capacity, we will have to add gamma df to the net safe bearing capacity, and it comes out to be 1443 kilonewton per meter square. It means if all the quantities are known, we can find out the bearing capacity, ultimate bearing capacity, net safe bearing capacity and ultimate safe bearing capacity of the foundation. Now in the example 2, it has been extended with all other data remaining the same. Only thing is that was for the general shear failure case. Now we are using it for the local shear failure. Now for local shear failure case, we have seen that tan phi dash becomes equal to 2/3 of tan phi and C dash becomes equal to 2/3 of C. That is, C dash will be equal to 2 by 3 C and tan phi dash will be equal to 2 by 3 tan phi. And using those values here, we obtain this phi dash is equal to 25 degrees and C dash is as 20 kilonewton per meter square. Now from the table for phi dash is equal to 25 degrees, we can find out bearing capacity factors for the local shear failure case given as NC dash, NQ dash and N gamma dash. So this is 25.1 as NC dash and 12.7 as NQ dash and 9.7 for N gamma dash. Now again in the Terzaghi's bearing capacity equation, if you substitute these values, we will get this ultimate bearing capacity as 119.0 kilonewton per meter square. Following the same approach, we can find out net ultimate bearing capacity as ultimate Q net ultimate will be equal to Q ultimate minus gamma df, then net safe by net ultimate factor of safety, and then finally safe as Q net safe as Q net ultimate by factor of safety will get Q net safe as 385.5 kilonewton per meter square. Then finally we'll get Q safe as Q net safe plus gamma df. We'll get it as 420 kilonewton per meter square.